Now again our next step, that is nothing but to find again more simplified way our numerator. Here x multiply with 1 upon x, so this x and this x both are cancel out, and remaining value, that is only 1. So we want to more simplify this log x plus 1 as it is, multiply with 1, so you can write log x plus 1 minus sign as it is. This x multiply with 1 upon x, the result, that is 1, and x multiply with 0, ignore it, divide by log x plus 1 whole square. Now here in numerator side, here plus 1 and minus 1, so both are cancel out, and the result, that is log x upon log x plus 1 whole square. And what we want to find, this is nothing but dy by dx, the whole term contain the dy by dx as it is, and this is our final answer, and that we want to prove. Just check it out. X raised to y equal to e raised to x minus y, we want to prove log x upon 1 plus log x whole square, and here that we want to prove log x upon log x plus 1 whole square. Now we move to our next question. Next question, that is sin y equal to x sin a plus y. Then we want to prove sin a dy by dx equal to sin square a plus y. So we move to or write our next sum, that is sin y equal to x sin a plus y, and we want to prove sin a dy by dx equal to sin square a plus y. This is our result, and this is our question, that is sin y equal to x sin a plus y. Just look at here, this x we want to take a common, and the result, that is sin y upon sin a plus y. So in previous sum we want to separate y value and find dy by dx. In this sum we want to separate x value and then x equal to sin y divided by sin a plus y. In previous sum we want to find the dy by dx, but in this sum we want to find first dx by dy. So we want to find dx by dy, same way dx by dy apply to here. So dx by dy, and whatever value our function of the x, that is replace here, that is sin y divided by sin a plus y, and then finally we want to take inverse dy by dx. So our result, that is in terms of dy by dx. So we want to find the differentiation, but remember here with respect to y. So we want to move further, write dx by dy term as it is, here we want to differentiation with respect to y, and just here y is a numerator term, here y is a denominator term, both the term contain y. So apply u by v rule. So when we apply u by v, then our step, that is denominator square, that is sin a plus y whole square, denominator term, that is as it is, that is sin a plus y. So we can write sin a plus y, then multiply the numerator with its differentiation. So d by dx of sin y, put a minus sign, that is rule of the differentiation of the division, then write sin y as it is, multiply with the differentiation of the denominator, that is d by dx of sin a plus y. Now again our next step, that is more simplified to our numerator term, because here we want to find the differentiation and again here we want to find the differentiation. So our next step, put a denominator term as it is, so divide by, here sin a plus y whole square, we can write sin square a plus y, both the meaning are same. Now write sin a plus y and we want to find differentiation of the sin y, sorry here with respect to y, so write dx by dy, differentiation of the sin y with respect to y, so sin y differentiation, that is cos y, so multiply with cos y because we want to find the differentiation with respect to y, so write dx by dy minus sin as it is, sin y as it is, and again sin a plus y with sin differentiation, so differentiation of the sin, that is nothing but cos, multiply with cos a plus y, and differentiation of the a, that is 0, and y differentiation, that is dy by dy, so ultimately becomes 1. So no any multiply value. So our next step, that is again find the more simplified way. So we can write here equal to sin a plus y into cos y minus sin as it is. Write this first term first, that is cos a plus y, and then first term to second, that is into sin y, and divide by sin square ay as it is. Now just image terms as a alpha, a plus y is a alpha and y is a beta. Now just image the numerator, that is sin alpha into cos beta minus cos alpha into sin beta. So this is nothing but sin cos sin. So ultimately with minus value, the result, that is sin alpha minus beta. So result, that is sin alpha, that is a plus y, minus, because here minus, so minus beta, that is y. So this is the simplified way to our old numerator term. When sin alpha minus beta, then sin cos sin with minus sin. Now put a denominator term, that is sin square a plus y as it is. Now we want to more simplify again our numerator, then this y and this y, both the y are cancel out, and the result of the numerator, that is only sin a. So we write it first, the result, that is sin a divide by sin square a plus y. Here just look at what we want to find, that is nothing but dy by dx. So dy by dx, that is continue, here continue, and finally here again continue. So write dx by dy and just image what we want to find, that is dy by dx. So when we want to find dy by dx and we have a dx by dy result, so dy by dx, that is nothing but take a inverse. So we can write dy by dx equal to, here numerator becomes denominator and denominator becomes numerator, so we can write sin square a plus y divide by sin a, and just image what we want to prove, that is sin a into dy by dx. So ultimately this sin a, that is goes to left hand side, that becomes denominator becomes now numerator, that is sin a into dy by dx, and here same value sin a into dy by dx equal to, here again equal to sin square a plus y. So here same sin square a plus y. So this sin a just nothing but we want to go to numerator side, and the result, that is sin a into dy by dx equal to sin square a plus y. So in this way we want to prove our result. So finally both the value are same. Now we want to move to our next question. Next question, that is y equal to x raised to x. Same value we want to find, here x and here x. So use a logarithmic value. So write our first sum, y equal to x raised to x, and we want to find the differentiation, but here x and here x both are in terms of power. So our next step, that is nothing but take the both the side log. So we can write log y and apply log to left hand side. So our result, that is log x raised to x. So here log y as it is, but here x raised to x, so this power comes forward. So result, that is x into log x. Now we want to find the differentiation of the dy by dx. So here y, but here log. So log differentiation, that is nothing but 1 upon y, but multiply with y. So result, that is dy by dx, multiply with dy by dx, put equal to sign as it is. Here x and here x both the term contain x with multiply sign. So use multiplication rule to find the differentiation process. So here first term as it is x, multiply with log x differentiation. So you can write d by dx of log x plus log x as it is, multiply with the first term differentiation, that is d by dx of x. Now again next step, that is more simplify to right hand side. So equal to x log x differentiation with respect to x, that is nothing but only 1 upon x, plus sign as it is, log x as it is, and differentiation of the x with respect to x, that is 1 with multiply with 1. Now again more simplify this x and here multiply with 1 upon x, so both are cancel out, and here first term remaining value, that is only 1, so we can write 1 plus log x, here 1 upon y dy by dx as it is, so we can write 1 upon y dy by dx. Now we want to find dy by dx only, so this y, that is goes to right hand side with multiply, because here division. So we can write dy by dx equal to this y multiply with 1 plus log x. So result, that is y 1 plus log x, but if you want to more simplify, then replace the y value, y equal to x raised to x, that is given to in problem. So replace y equal to x raised to x, so result, that is x raised to x multiply with 1 plus log x, and finally write dy by dx. So this is our final answer. The result, that is x raised to x 1 plus log x. So result of the y is equal to x raised to x, that is nothing but x raised to x 1 plus log x. Now we move to our next question. Next question, that is x raised to y into y raised to x equal to 1. So first of all we write it, that is x raised to y into y raised to x equal to 1. Now again we want to find the differentiation, that is dy by dx, but here x raised to y, so here x and y in terms of power, here y and x in terms of power. So next step is take the log both the side, so you can write log x raised to y into y raised to x equal to log 1. Now whenever log that is applied with multiply sign, put a addition sign, so log x raised to y, more simplify to left hand side, this multiply becomes now plus log y raised to x equal to sign as it is, and log 1 the result, that is 0. Now again we want to more simplify to our left hand side, here x raised to y in terms of power and here log, so power that is comes forward, so result that is y log x plus sign as it is, here again same raised to x and here log, so raised to x that is x log y, so result that is x log y, put equal to sign and 0 as it is. Now our next step, that is nothing but take a differentiation, so here y and here x, so ultimately we want to go to multiply rule of the differentiation. So in this way, first step with multiply with differentiation, multiplication step, here x and here y both the term contain again in multiplication, so you can find the differentiation using multiplication rule, that is u into v rule. So here first term as it is, differentiation of the second one, so you can write d by dx of log x plus